This time, folks, we're going to talk about the motion of stars, and in this section we're also going to talk about binary stars. So let's start out by talking about motions of stars. When we try and describe how stars move, there are two different kinds of motion. One is called proper motion and one is called radial motion. These are concepts I want you to understand, and you also need to know the vocabulary words. What do these two terms actually mean? So when we talk about proper motion, what we're referring to is a star moving relative to other stars in its background. Classic example is something called Barnard's star, and Barnard's star is famous because of the fact that it has a relatively fast proper motion. Astronomers for a long time have watched it move relative to the stars that are so far away that in a human lifespan we don't see any change in motion. But Barnard's star, here's a picture of its location in 1950, and here's a location of it in 2010. So in 60 years, it has moved a great distance relative to the background of stars. If we go back to the previous slide, this illustration here is what we're talking about when we start talking about proper motion. Stars moving left to right or up to down. This proper motion of stars is also one of the reasons why constellations are changing shape. 50,000 years ago, the Big Dipper looked something like this. Today, the Big Dipper might look something like this. And in 50,000 years in the future, it's going to look more like a big swirly S or something like that, because the stars are moving, but sometimes they are moving so slow we can't really tell. The other type of motion that occurs with stars is something which is known as radial motion. Now, sometimes stars are moving towards us and sometimes stars are moving away from us, and they are right in front of our eyes when we see this motion towards us and or away from us. And I have that backwards, towards us and away from us. So how do we determine that? Well, we determine that with our old friend, the Doppler effect. And the Doppler effect is that change in pitch, frequency, or color that occurs when an object is moving towards us or away from us. So stars that are moving away from us are going to be redshifted. Redshifted means that, let's say that these lines are the Fraunhofer lines or these spectral lines of hydrogen, and when an object, a star, is moving away from us, those same lines are present, but they are just shifted a little bit towards the red end of the spectrum. If a star is moving towards us, the same spectrum, same hydrogen spectrum that we are used to seeing, will be shifted, blue shifted, a little bit towards the blue end of the spectrum. So towards us is blue, away red, and this is radial velocity if a star is moving away from us or towards us. The rest of this video we're going to talk about binary stars. Bi means two, as in bicycle. Bicycle is a cycle with two wheels. If a country is celebrating their bicentennial, bicentennial is 200 years old, and the United States is well over 200 years old. So a binary star are two stars that are actually together in a system. Over 50% of the stars that we actually see in the sky are part of multi-star systems or binary systems. Matter of fact, most are. Our little sun is unusual because of the fact that it is a solo star and doesn't have a binary companions. Now, not all stars are just in two-star systems. Many of them are in multi-star systems, and they can be 8 or more in a big group of stars that are all kind of hanging out and gravitationally bounded together. When you're looking at binary stars, there are different types of binaries. So One type of binary star system is called optical doubles. Optical doubles are stars that look like they're close together, but they're not. They're so far away, they're not gravitationally bound together. So from the position on the Earth, we see two stars next to each other, and they sure look like they might be a binary star system, and they're really close together. But when we start actually measuring the distances to those stars, one might be light years away from its companion. And that means they're not really binary stars. They just kind of look like it compared to our vantage point. When you have binary stars, they have a tendency to orbit a common center of mass, or a common center between them. Kind of like when you were a little kid and you would teeter-totter. If you had a big kid and a little kid and they wanted to teeter-totter together, they had to move the fulcrum or the pivot point of the teeter-totter for happy teeter-tottering. But there is a balance point between a heavy object and a light object. Stars are going to do the same thing if you have many of them, and they are going to orbit a common center of mass. So it's not like one star is standing still and my pen has gone stupid. No, 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 no. Sorry. Visual binaries, back up, 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 up. There we go. Okay. Do I have my pen back? I apologize. That was kind of silly. When you have two stars, they're not going to orbit each other. One's not going to stand still and the other one's not going to orbit around it. They're going to have a mathematical point in space that they both orbit around. We're going to end this video here, and I want you to look at this small little video about stars orbiting a common center. See you next time.